In this video I'll talk a bit about member function templates, which are function templates that are members of a class or struct or a class or struct template. Member functions that have their own template parameters are considered to be member function templates. Class or struct templates already have generic functions, right? But generic functions or class or struct templates are not referred to as member function templates. Again, member function templates have their own template parameters. Let's look at a few examples in Visual Studio. In this example, I have a helpers struct, so I just called it helpers instead of entity in this example, and I have an interchange or swap member function template. We used this as an example in a previous video, but in this example, this interchange function is now a member function template. You can see it has its own template parameters. The struct itself is not a template, okay, it is a regular struct. Then in main I define Q and W. Q is set to 33 and W is initialized to 55. I print those out. Then I'm going to swap the values. I construct helper, which is of type helpers, and then I do helper.interchange, and I pass in Q and W, and the compiler is going to deduce the type argument of int, and then I go and print those out again. Build and run, and you can see that works fine. Of course, we can also specify the type argument, then we'll get this sort of syntax. Before we move on to the next example, I would like to use the static keyword again. Just another example with the static keyword. So this is now static. And what do you think this will allow us to do? Well, if I go back to main, to actually use that helper struct, I now have to instantiate it each time, right? But maybe I just want to use the helper functions that are in that helper struct or class. So instead of doing this now, what I can do is I'll comment that out, and then all I have to do is I have to qualify the interchange function to the struct type, and if I build and run, you can see that works fine. So what's great about this is you can create some helper struct or class that contains member functions or member function templates that you can use over and over again, or maybe some math library or whatever it is that you need, and then you can put that in a header file and include it in all of the source files where you need that. As I mentioned, when it comes to template, I recommend that you define your member functions within your class definitions. But let's say you do want to separate things out, and your struct or class is also some template. I'll change things around a bit, so I have the template prefix for the struct, so the struct is now a template as well, and of course you can use that for something else. So the struct can have some member of that type. Let's say for some reason we want to separate out the declaration and the definition of this function. And I have to qualify this now. And I have to qualify this interchange to the helpers, but helpers is now a template. So, as we've seen before, when we qualify a member function like this, we have to provide the angle brackets and then specify the type parameter. But of course, helpers here does not take in u, it takes in t. So how can we fix this problem? Because this works right, we can pass in u. The function has u for its parameters and everything, but it does not have t to specify in these angle brackets. So again, I can go and copy this template prefix and then I can paste it right here. So the syntax is a bit weird. The template prefix, we have two templates in here now. This one right here is for the type parameter for the class itself, and then we have one for the type parameter, in this case u, for the interchange function. I'll scroll back to main now, and of course helpers is now a struct template. So what I need to do is I specify the type parameter such as int, for example, and build and run, and this should work fine. As you can see, that works fine. And without the static, okay, this is what it'll look like without the static. And we go back. Now we'll have to instantiate the helper struct again. In this case, we'll have to specify the type parameter because again it's a struct template. And then I can do helper.interchange and build and run, and that works fine. I'll just scroll back up to the helper struct template. One important note is that member template functions cannot be virtual functions. So if I try and make this interchange member function template virtual, I will get an error. I can Control B to try and build that, and we will get an error. Member function templates cannot be virtual. Member template functions can also not override virtual functions from a base class. That is when you have a base class virtual function, right? And you try and override that in a derived class, but you try and override it with a member template function, you'll get an error. Okay, I hope you found this interesting, and I'll see you next time.